handing me things, so I'm not as on top of it as I would like to be. But I do actually have the quizzes you took yesterday graded. So I can hand those back to you today as well, so you can see how you did. Most people did well. I consider it was out of 70 points. If you made over 60, I consider that was a good job. I need help with these math workshops. Lots of free points available. 13 asks about, they want us to rearrange your formula. I'll give you a point if you can tell me what this formula is. The challenge problem? Number 13 has a formula. I'll give you a point if you know what the formula is. Oh, wait. Yes, dear. You can have a point. This is the distance formula. This is the distance formula. So that's why it's D equals, because it's distance equals whatever, and you're supposed to use your 2 points to figure that out. However, they want us to rearrange these equations and instead solve for x2. So first things first, we've got to get rid of that house. We've got to kill off the radical. What do you do to get rid of a radical? You can have a point. You got to square both sides. A square root is killed off with a square. That makes sense. Square root, squared, they sound similar. So D squared equals, so we did all this to kill off the house, so we just have x2 minus x1 squared plus y2 minus y1 squared. What variable are we solving for? We're solving for we're solving for x2. So right now, should I move the x's over or should I move the y's over? It makes sense to move the y's over, get a point. He's going to take all the points today? Interesting. So minus y2 minus y1 squared equals x2. What is x1 squared? Ellie, is he just that loud jamming or am I in my mind? He's that loud. Turn it down. I can hear you. I can hear you. Yeah, I can hear you. Thank you. Okay, so we've got this, which is d squared minus y2 minus y1 squared equals x2 minus x1 squared. We still don't have x2 by itself. We've got to get rid of the squared. How do we kill off the squared? We'll have to take the square root of both sides. If we take the square root of both sides, it's basically opposite of what we just did a few minutes ago. We killed off square root with squared. Now we're killing off squared with square root. So we have square root of d squared minus y2 minus y1 squared equals x2 minus x1. And I really don't have to put it in parentheses. I don't know why I put that. There's no need. No, I know what you're trying to make happen, but because of that minus operation in between, it can't work. Okay, is x2 by itself? The easiest part of the whole problem happens right now. How do I finish this thing? You add x1. I heard it from Nick and Angel, so 2 and 4 at a point. So it's square root of d squared minus y2 minus y1 squared plus x1 equals x2. When you add x1 to both sides, x1 just suddenly doesn't get to jump under the radical. He doesn't get to jump under the house. He wasn't originally in the house. He can't suddenly join the house. It's not how houses work. Okay, so it looks like a hot mess. It's no better than the original. The original had d's, y2s, y1s, x1s, x2s. I mean, it still has all the same elements. All we've done is rearrange the equation for a different variable. But on the ACT, this is the kind of question they would ask, because if they asked 2a plus 4b equals 6, and they said solve for a, well, that's kind of easy. Most people can say, oh, it's 2a equals 6 minus 4b, divide by 2. Like, that's way too easy. Too many people would get it right. I changed my variables at some point. That's a b. That's a b. So too many people would get that right. So they've got to make it a little more complicated. The less numbers they put, the more variables they put, the more people who will give up. Hence why it makes it a harder problem. So I've seen a lot of problems where they take a normal formula like the distance formula, the midpoint formula, a formula you should recognize, and then ask you to solve for a different variable. Okay, on number 14, What is this the graph of? I heard it from 2 and 5 at a point. It's a piecewise function. Did we do any piecewise functions that had, these are parabolas or any kind of, did we have anything like this? No, we had straight lines. We did lines and they leaned different ways, but they were lines. They had no curve. So this one, thankfully they're not asking us too much about it. We are actually just going to interpret some things. Let's read it through. It says, use the graph of the piecewise function h of t and the table to answer the following questions. The point 3, 5, so 3, 5, is not the vertex of a parabola, but the point 5, 6 is the vertex of a parabola. Don't know if that's useful. Still going to put a little dot on those points just to help myself. It asks, what is the value of t when h of t equals 4? What is the value of t when h of t equals 4? Where is h of t? Is that the x or the y-axis? You can have a point table too. H of t is the y-axis. They said h of t is 4. So when we're at 4, if we reached out, we touch our function here, and what is the x value there? 7. So the value is 7 because they're really asking, hey, when the y-coordinate's 4, what's the x-coordinate? And it's 7. Now, I like graphs, so I don't mind reading a graph like that. We had to skip over this point because it was an open circle, but I don't mind reading a graph like that. But what's great about this question is they also gave you a table of values. So literally, you could go to h of t is 4, and you see there's a 2. H of t is 4, and you see there's a 7. You might then have to look at your graph to make sure, like, hey, it really is 7. Like, you would have to confirm since there are 2 options, but you could use your table to help with this as well. Okay, so that's A. B is asked differently. They say, what is the value of h of 3? So they're saying when the x value is 3, what is the y value?
No, 5. Wait,
When the x value is 3, what is the y value? So when t is 3, what is h of t?
4, yeah.
That would be incorrect.
No, why did I say that? Okay, so when h is 3, which is the y value, is 3, it's negative 6, right? 5. No.
When x is 3, so we're at 3 on the x-axis.
Oh,
People were
that's
saying
5.
that it was 4, but 4 would be wrong because it's an open circle at 4. We have to go to 5, so it's 5. So the value of h of 3 is 5. The next one is nice. What are the coordinates of the point? So they want the x and the y value. Where h of t has an absolute maximum value. So if we're the highest point we reach on this y-axis, where's the highest we can touch on the y-axis? Is it 5 or is it 6? It's 6. We can reach over at 6. So the y-coordinate's for sure 6. What is the x-coordinate then? 5. So our point is 5, 6. Now here's something we haven't spent a lot of time on, which does come up a lot in future math classes, especially when you get to like calculus. This is a very important concept. So we talked about domain and range, but we haven't talked about increasing and decreasing. So increasing and decreasing, the easiest way to explain is if we were riding a roller coaster. So we're going to pretend this is a roller coaster. It's a terrible one because there's some points where we die. Because literally we jump from here to here. How did that happen? So we're going to die twice, but that's okay. If this is our fake roller coaster and we're riding on it, at which points were we going downhill because that was decreasing, and which points were we going uphill because that's increasing. So where are we decreasing? So if I start here and I go to here, am I increasing or am I decreasing? Decreasing. So from -7 to 1 on the x-axis, I am decreasing. So I'm going to say -7 to 1. Why am I putting it in brackets? Because they're close, so we can actually touch it there. You can have a point for that, 2 and 3. Okay. Then, so I guess we die, something happens. We jump to this next part of our roller coaster ride. So from here at 1 all the way up until 3, are we increasing or decreasing? We're increasing or decreasing? Okay, I'm making sure we're on the same page. Every group can have a point. So we're going from 1 to 3, but since it's open circle at 1, I'm going to put my parenthesis. Okay, so we went down the hill, there was a jump, we went up the hill, there's another jump. So now we're starting back at 3. From here to here, am I increasing or am I decreasing? So from 3 to 5, I'm increasing. It's 5 on the x-axis, so from 3 to 5. Now, one could argue that this is silly, this notation right here, because we're saying I could touch it at 3, and then I pick up at 3 and go to 5, and I get that. So if you're wanting to write 1 to 5, I understand. But I'm going to leave it like this because I think that clarifies, P.S. there's a jump. So I'm going to leave it like that. But one could argue we might want to rewrite this 1, 5, because from 1 all the way until 5, we were technically increasing. But I feel like then you're not specifying about that weirdo jump. So I'm going to leave it as is. Okay, and then from 5 on down, we were going increasing or decreasing? We're decreasing. So from 5, and we can touch it, all the way until what number? Okay, every single time we've been using x values from -7 to 1, because it said, it asked us to. So -7 to 1, and then 1 to 3, 3 to 5, and it makes sense, 5 to 9. And then our roller coaster ride has finally ended. Daniel, you can have a point for the 9. Okay, are there any questions about this? It's kind of deep, but not really. So if it was an actual ACT question, I can see A, B, and C being worded as they are with multiple choice options. But as for D, the good news is you wouldn't have to write the intervals yourself. You would just have to pick from a list. So back to the little hints and tricks we know about when to use a bracket, when to use parentheses, that kind of thing ought to help us out. Okay, go to page 9 of your notes if I hadn't said that already. We have 2 things left to learn about matrices. 2 things. If I were you, I would press second memory management. I would delete the matrices that someone typed in first period because they already typed stuff in and you would like it gone. Hello.
You might have to run an update on your computer.
That'd be awesome. Oh, that would not be awesome. Because I'm recording. How would we do the things?
I can come back.
Okay. I didn't even think that through. Thank you, Cooper. No. No. Yes, dear. Yes, dear. Okay, so if I were you, I would press second memory, and then I would clear memory management, go to matrix, and clear out the matrices. That way you don't have to deal with first period and what they typed in. For a third time, yes. How much I enjoy that. Second, memory. And it's really more than the third time because I did it the other day too. Memory management. Matrix. And then if you have any matrices, press delete next to them. Okay, so if it's your calculator, then no, it wouldn't. Okay. So, before I use words, let's just go ahead and, so there are 4 main problems today, and since we've already got the calculator on and hot and ready to roll, let's go ahead and type in these 4 problems. I'm going to type 1 into A, 2 into B, 3 into C, and 4 into D. So I'm trying to save us some time. I'm going to second matrix, edit, and type number 1 into A. So 2 by 2, 7, -5, 2, -1. And like I said, I'm going to do number 2. I'm going to type into B. Number 3, I'm going to type into C. And number 4, I'm going to type into D. Okay, when you have all those typed in, we're going to have to talk about math for a few minutes before we come back to it. But we've just saved ourselves a bunch of time. Because those are our full problems today. I'll give you another minute. I've still got one or two type in. What were we talking about 2 days ago before we took our quiz? It wasn't on the quiz. 5 get a point. We're talking about determinants. We're actually going to talk about why they're useful today and why we need them. Because otherwise they seemed kind of crazy. Why were we doing this weirdo thing with diagonals? Why do we need to know this number? So that's what we're going to talk about today. We're also going to talk about the coolest thing, I think, about matrices, which is that they have an identity matrix. So the first blank in your notes is the word identity. Okay, so the identity matrix, and they've given you the example of a 2 by 2 and a 3 by 3 below. It's a square matrix that would multiply by another matrix equals the same matrix. So, if you notice on the identity matrix, there are 1s on the diagonal and 0s everywhere else. So if I asked you to write the 4 by 4 identity matrix, what would you tell me in the first column?
1, 0, 0, 0.
What would you tell me in the second column?
0, 1, 0, 0.
What would you tell me in the third column?
0, 0, 1, 0.
What would you tell me in the fourth column?
0, 0, 0.
Okay, I'm sorry, but no one at 1 participated, so every other group except 1 had a point. So that's the 4 by 4. If we want to do the 5 by 5, we could too. It's really not that hard to figure out. We need 1s on the main diagonal, 0s everywhere else. Okay, back to what the English said. It said if you have an identity matrix and it's a square matrix, that when multiplied by another matrix equals the same matrix. So in the way in math, 2 times 1 equals 2. If we take our matrix, so I'll make one up, 3, 4, 5, 6, and we multiply it by this identity matrix, we're going to get back 3, 4, 5, 6. So an identity matrix is just like when we multiply in regular math class by 1. It ends up giving you back what you already had. So it's really cool. And then you're distracting me. I don't know why though. I don't know why. I'm like, my ADHD kicked in on you. Okay, so the identity matrix is a square matrix, 1 for every element. We already talked about that. So I explained it in like using numbers up here. They explain it in that first main box. They use variables to explain it. So if you want to look through that, you can. But basically, we would love to see identity matrices because they make life so much easier. 2 matrices are inverses of each other. If their product is the identity matrix. So if we have 2 matrices, whatever they are, and we multiply them together, and we get 1, 0, 0, 1 back, then those matrices are inverses. So if we multiply 2 matrices together and we get back the identity matrix, then this matrix is an inverse of this matrix. Okay, and you're like, why? Why do we need this? Why is this necessary? What on earth are we doing today? So we've learned how to add. We've learned how to subtract. We can multiply by a constant. We learned how to multiply matrices. What's the one operation we haven't discussed? We're not going to. You can't divide with matrices. It's not good. So, in life, if you have the problem 2x equals 3, you say, oh, okay, divide by 2, x equals 3 halves. Like, great. I can do division in normal math, but with a matrix, which we decided you represent with a capital letter, if you have like ax equals b, you can't divide by a. You can't divide by matrix A. Won't work. We don't allow that. You have to multiply by the inverse. So the only way to kill off A is to use A inverse. So I like to think of an inverse as an evil twin. And the notation makes it look that way too. So if we're wanting to kill off A, we need his evil twin A inverse, which we put with a little -1. That's how we know he's the inverse. So if we use A inverse, we'll kill off A. But as is always in math class, if we use A inverse on the right side, we've got to use A inverse on the left side and vice versa. So if we use A inverse to kill off A, we still got to use A inverse on the other side. When we use A inverse and A die, and you have X equals A inverse B. Okay, so I went super mathy on you, and I'm going to leave that there. I'm going to say it slowly again, and then I'm going to let it go like Elsa. Elsa from Frozen. Okay, so we can't divide with matrices. The only thing we can do to get rid of a matrix that's bothering our variable is to use the inverse. When we use the inverse, A inverse and A, they end up dying, and you finally get X by itself. But on the other side, you have to actually multiply it out, and you'll get a final answer. That's a matrix of A inverse B. Now, do we in Algebra 2 with trig actually make you solve set up equations like this? No. Do you need to kind of understand this concept in order to be successful in pre-calculus and calculus and beyond? Because I'm telling you, a lot of college math classes were matrixy crazy. Yes. But as for us, all I need you to focus on today is basically, we can't divide, so today we're learning about inverses. Because we've learned all the other operations, and since we don't divide, we've got to talk about inverses. Okay, so two matrices are inverses. We talked about if when you multiply them, you end up getting ones and zeros. I have seen a standardized test question that asks, like, are these two matrices inverses? And all you would have to do is multiply and see, am I getting the identity matrix? Yes, no. That would be easy. But people overthink life. Okay, if you are a nerd like me and you want to know how to calculate this by hand, the way you want to know how to do a 3x3 by hand, it's really not that deep. Do you remember when we did the determinant, we did the diagonals? So we did AD minus BC. Notice that determinant is in the denominator. And then they flipped the 2 on the first diagonal, and they changed the sign of the 2 on the second diagonal. And every single time, if you take your original and do this to it, and you multiply the two together, you're going to get the identity matrix. Now, in Algebra 2 with trig, regular Algebra 2 with trig, do we actually expect you to understand how to do that yourself? No. You and I both know we done warmed up our precious calculator because we're going to figure out the calculator button for this. But it is nice to understand the math sometimes. Okay, so we're doing these 4 problems. And we've already typed in the matrix. Thank you. And life should be easy except for one sentence, one part of the directions. What part of the directions are concerning today? If it exists. You can have a point for that. If it exists. So what does that imply?
It could not have an inverse.
It could not have an inverse. So the first thing we got to check on all our problems is, does it exist? So if it exists, we've got to answer that question first. How do we decide that? I told you 2 days ago. We're okay with the determinant that's positive or negative. There's only one value that makes us worry. Your determinant cannot be 0. So if it exists, so check determinant. And then you might want to write a note to yourself, determinant cannot be equal to 0. Okay, and if you're, again, a math person and trying to figure out why can the determinant not be 0, notice in our formula, our set little design for an inverse, notice that AD minus BC, that's the determinant, and it would be in the denominator. And you know we're never allowed to put something that's 0 in the denominator. So that's why it can't be 0. But you don't even have to remember that. You just have to know 0 can't happen. So if we're going to go through and check 1, 2, 3, and 4. We're going to press the determinant button. And if we get 0 on any of them, we're done with that problem because the inverse does not exist. So let's do 1, 2, 3, and 4. What button do you press in your calculator to check the determinant? And then what? Math, and then it's which one on the list? 1. So you press, I want to do the determinant, and I'm going to do matrix A. I press enter. I get 3. So the determinant of A is 3. I'm going to write that down. Determinant 3. DET 3. Okay, so I need you to check all 4. So let's make sure he's not crazy. The determinant of B is 0. So we'll come back to that one in just a second. Nick was right. He can have a point. The determinant of 3 is Gilberto get a point. So we want math, determinant, second matrix, C. That is 19. Okay. And you can have a point for that, Karen. Does anyone not know how to check the determinant on their calculator? Because again, the first step is checking the determinant. Because we got to worry about, does it exist? Because there's already one that I'm done with. Which number am I done with? 2. And what am I going to put? Well, but I'm going to quote the directions back at them. Yeah, I'm going to say does not exist. So inverse does not exist. Now, if you put not possible, no solution, I'm going to take off no. But again, quoting back the way they said it, inverse does not exist. So we're already done with number 2. So I'm going to show you how to do number 1, and then I'm going to jokingly say do 2, 3, and 4. There's nothing else you can do on 2. But if you wanted to check it with your calculator, you could. Okay, so the inverse does not exist. And then you're like, okay, Ms. Compton, so I need to find the inverse of this matrix. So, and again, like I said, this matrix times whatever we decide is the inverse should give us the identity matrix. So Nick could check himself. And of course, there is a button on our calculator that looks like that inverse button. Do you see a -1 button?
Yes.
Yeah, so I'm going to say second matrix. I'm going to tell it A, but I want A inverse. So I'm going to press the button that has a -1 exponent. It says x to the -1. It's what you've been pressing that says matrix. Just don't do second matrix. So now I have, not coincidental, very intentional, very intentionally designed. So now I have A raised to the -1. Does everyone see that? Does anyone not know where that is on their calculator? Okay, well press enter and be brave. Okay, that's lovely, good for them. Wouldn't you rather see some fractions? Did you know your calculator can change things from decimals to fractions? Press math. Tell it you want a fraction. It'll change your answer to fractions. So instead of trying to tell me -0.33, instead you could tell me -1/3. And suddenly our life is so much easier. So the answer to number 1 for the inverse is -1/3, 5/3, -2/3, 7/3. Okay, there is a really good question you could ask me here. It would make my soul happy. Actually, there are 2 good questions you could ask me here. Okay, well, just to prove a point to you, if I were to do second matrix, I tell it B, and then I tell it B inverse, even though I know it's not possible and does not exist. So does my calculator. That's why it tells me there's an error. So if your calculator gives you an error, either 1, you typed stuff in wrong, or 2, you were never supposed to do that problem anyway because it didn't exist.
I know, I was getting frustrated. The workbook. No, not the workbook, but the quiz yesterday because I thought I was having in something wrong because it kept saying quiz.
Because you didn't check the dimensions on your own first, yeah.
I mean, I did, but like, I typed
Yes. That's a third good question that could get you a point. So one way you could handle this is you could take your answer. You could say second answer, and then you could multiply it by A to make sure you really do get the identity matrix. So for sure, I am positive that this thing I wrote in pink for sure is that inverse, because when I multiply these 2 matrices together, I do get the identity matrix. So you can have a point for that. Okay, while you're thinking of what good question it is that you ought to ask, go ahead and someone tell me the answer to number 3. 4, say page only, although I'm going to give everybody a point for it, page only, because she's easy to listen to. 4/19.
7/19. 1/19. -3/19.
Okay, perfect. And then I need the last one. Keep going, Nick.
-1/2.
Keep going, Nick.
2 to 5.
Uh-huh.
1/2.
Okay, and Nick, you can get a point. Okay, so does anyone need me to type those in my own calculator and show you how to do that? Okay, so if I did second matrix, I go down to, let's say, D, because I typed number 4 in D, and then I tell it I want the inverse. It gives me that, which sounds great, but I'd rather see fractions. So I press math, fraction, and I convert it to fractions.
Can you show your calculator and give me fractions?
I don't. I bet you can if you went to mode. No, I don't see an option for that, but that is smart. Oh, it says auto, so you could set it to fraction, yes.
Oh, how cool.
That is cool if you're using your own, but if you're using mine, you know it's never going to stay that way. Okay, so are there any questions about this? Yes, dear, ask me.
Determine the denominator.
You can have 2 points. So, I turned it upside down. Woo. That was one of the 2 smart questions you could ask. There are 2 things that we should notice. Gilberto's noticed one of the things. Notice that our determinant was 3, and that all our denominators were 3. Notice our determinant was 19, and all our denominators were 19. Our determinant was 10, but all our denominators weren't 10. But they probably were simplified fractions. I bet it was 4/10, and they reduced it to 2/5. I bet it was 2/10, and they reduced it to 1/5. So originally it was. Your calculator's just nice and already reduced it for you. Okay, that was one good question. Now I'm listening for the other good question. I don't know, maybe first period was just on fire today.
Okay, let's write the decimal form.
If you write decimal form, and I have to take the time to plug it in my calculator and see if your decimal really does match on my stuff. Whew, I'm gonna stare at your stuff a little harder than you want me to, I believe. I don't really think you want to do that. Yes, dear.
Why don't there have to be like 4 fractions instead of just 1?
You can have 2 points. Wouldn't it be nice? And you can do this, but you don't have to do this. You can just be done and say, I'm done here, Miss Compton, I can't. But wouldn't it be nice if we pulled out the fraction, maybe pulled out the 1/19, and now instead our problem is 4, 7, 1, -3? Wouldn't that be so much prettier? So you could pull out basically 1 divided by whatever that determinant is. And then you'll have pretty whole numbers left over. You don't have to do this, but for those of us who don't like the look of it, I'm with you, it's ugly. That would make life a lot prettier. Agreed. Are there any other questions about this? You have a couple problems in the workbook. It's page 43, 9 through 14. As of today, we have you see we have 6 questions left. That's it. 6 questions left of new things. If Tylen were to flip to the back, she'd already be on the study guide. So Tylen could go ahead and start the study guide. We are going to talk about the 6 final questions, the last topic. We're going to start our study guide. Monday we're going to finish up our study guide. We're taking a test on this on Tuesday.